How to find the end behavior of polynomials. Let's go. All right. So this is a problem, but before we do, let's look at a chart. So first example in the chart for f of x equals x squared. So we know it's a parabola moving upwards. So you notice that the exponent is even and the coefficient is positive. So as x approaches positive infinity, because larger, f of x becomes larger in the positive direction. So positive infinity. As x approaches negative infinity, we have f of x also approaching positive infinity. It becomes larger and larger and larger in the positive direction. Okay, that's our first example. Our second example for our chart is f of x equals negative x squared. So notice here that the parabola is downward facing, exponent is positive, is even, whereas the coefficient is negative. So as x approaches positive infinity, larger and larger, f of x becomes negatively larger, so minus infinity. As x approaches negative infinity, f of x is approaching negative infinity, larger and larger in the negative direction. Okay. So third example in our end behavior chart is f of x is a cubic function, and notice here that the coefficient is positive and the exponent is odd. So the graph looks this way. As x approaches positive infinity, f of x becomes larger and larger, becomes approaches positive infinity. As x approaches negative infinity, f of x becomes larger and larger in the negative direction, so approaches negative infinity. Okay, and then our final example in our chart is f of x equals negative x squared. Notice that the coefficient is negative and the exponent is odd, so the graph behaves this way. As x approaches positive infinity, larger, f of x is becoming larger negatively, so f of x becomes negative infinity, approaches negative infinity. As x approaches negative infinity this direction, f of x is becoming larger and larger positively, so becomes positive infinity. So let's look at our problem then. Now our problem, the largest exponent term is 4x cubed, so that's what we're going to use to find the end behavior, because that's what's going to determine the behavior of the polynomial. Okay, so notice that the exponent is odd and the coefficient is positive, so we're going to use that example I'm circling, and on the left bottom example, f of x equals x cubed. So as x approaches positive infinity for this problem, f of x also approaches positive infinity. X approaches negative infinity, f of x approaches negative infinity. So that is our final answer, and it basically models the third example that we showed in our chart. Okay.